Hello, good morning, everyone. Welcome back, or should I say good afternoon, everyone. Welcome back to Algebra 2 with Pre-Calculus. This is Mr. Malcolm. I'll be walking through your Think About It section as usual. Please use this opportunity to be prepared. Place your notebook, laptop, graphing calculator, and pencil on your desk. Please update the title, which is the Pythagorean identity, and the date on the next empty page in your math notebook. Ensure your environment is ready for a Zoom class meeting so that you can turn on your camera if you choose to do so, and it won't be a distraction. All right, so at this time, please pause the video and get ready, and I'll see you once you're ready. Alrighty, welcome back. Thank you for updating the date and the title for today. Now, for today, our lesson is entitled the Pythagorean identity. So we're going to use the Pythagorean theorem to map out the identity for this triangle, and the same triangle that we've been using for this whole section. All right, so our aim is, given sine and cosine, students will be able to prove the Pythagorean identity. Okay, so let's think about it. Please take a moment and read through the question. Pause the video, read through the question, try to answer it, and then return to the video, and I will then walk you through the solution. Right? Take a minute, think about it, or take 5 minutes, think about it, and get through, and then return. All right, go. Alrighty, I take it that you went through, and hopefully you are able to get through the Think About It section, and that you don't have too many questions. But if you do have some questions, please reach out to me during class, and I will see to it that your questions are answered. Hopefully, once I go through the debrief, you'll be able to answer these. Okay, so it says use a diagram given at a point on the unit circle to answer the following questions. Okay, so here's the diagram. It says identify the ratios for sine and cosine using the values x, y, and 1. Okay, so if you remember from before, for sine is given by the opposite over the hypotenuse. So opposite would be y over hypotenuse, which is 1. Cosine is sine of theta, cosine of theta is adjacent over hypotenuse. So adjacent x over hypotenuse, which is 1. Okay, that's out of the way for A. B says, given that the Pythagorean theorem says the small side plus the big side squared equals to the hypotenuse squared, given here, how could this equation be written given the equations you found in part A? Rewrite the expression and explain. Okay, so to rewrite, we would, instead of having x, okay, let's do the x squared plus y squared equal 1 squared or 1. Let's put the 1 squared so you don't get confused. Okay. We could rewrite this as for the x, this side would be the cosine. So let's put cosine square theta plus y side would be sine. So sine squared theta equal to 1 squared or 1. Same thing. Okay? Part C. Is the equation you wrote in part B true for all points on the unit circle? Would it be true for all points on the unit circle? Take a second and think about that. And the answer is yes. How do we know that it would be true for all points? If you notice that the unit circle, for all of these, the hypotenuse be 1, okay? And for all points, you would still have the same x and y coordinate, where the x would be the cosine and y would be the sine value, okay? So if this part is true, then this part also must be true, okay? So we can use this logic. If A is equal to B and A is also equal to C, then B must be equal to C. That's the logic. Therefore, if x squared plus y squared equal 1 is true, then cosine squared theta plus sine squared theta equal 1 must also be true. Okay? All right? Where in the equation, this part would be B, and this part would be C, and the 1 would be A. Okay? To make this statement true. Okay? All right. Now that would be our think about it section for today. Hopefully this helps, and I'll see you in class in just a moment.